Hello and welcome to this seminar on advances in dryland cropping in the Pacific Northwest. My name is Isaac Madsen and I work with Dr. William Pan at WSU. We both work specifically in soil fertility, but today we'll be talking more about the rotational diversification and intensification in inland Pacific Northwest as part of the REACH project. So just right here we'll be looking at the map of the inland Pacific Northwest and the breakdown in agroecological classifications that has been a product of the REACH project, looking at where there's room for adaptation and intensification inside of this region. As you can see, there's three main zones in the inland Pacific Northwest that are dry land that we'll be talking about today. So the first is the annual crop region. This is a smaller region that's dominated by annual cropping, so it's usually a combination of winter and spring crops. And then the annual crop fallow transition, which is in yellow there, and this is a zone where you essentially have a mix between annual cropping and using fallow as a tool to store moisture. And then we have this third location here, which is grain fallow, and that's where you have a winter grain and a fallow year, and then another winter grain and then a fallow year. Moving on to this table, we can see the breakdown of the acreages of each of these areas in the top bar of this table. So you have the annual crop on the left with around 1.4 million acres, the transition zone with 1.85 million acres, and the grain fallow, which is by far the largest at 2.52 million acres. Comes out to about a total of 5.8 million acres of dry land farming in the inland Pacific Northwest. If we look at the breakdown within these zones between fallow and wheat and then spring wheat and other crops, you can see that most of them are pretty similar as far as the percentage of ground that is covered in wheat in a year. So the annual crop has 40.8% winter wheat, the transition is 40.7%, and then the grain fallow is 45.1%. What's really interesting to look at here is that the fallow in the grain fallow rotation is essentially other crops or spring crops in the annual location. So you're using that, your wheat acreage is staying the same across the different regions, but essentially as you get higher rainfall, you're replacing the fallow with spring wheats or spring crops, some spring wheat, also spring barley, chickpeas, lentils, peas, canola, and alfalfa. And so really what we're talking about today is diversifying this. So 45% of the acreage in grain fallow is wheat. We're talking about diversifying that and potential intensification in the transition zone, which is maybe moving spring crops further out there into that region. And we're going to focus on sort of three opportunity crops right now that are really good as far as there's the research, the economics, everything's coming together where they can actually take off now in this region. And a large part of that is the REACH project, and so we'd like to focus on that. So these three crops are winter peas, winter canola, and spring canola. And I'll start by talking about winter peas. I'm actually going to start with acknowledgments because most of this work was done by a team of WSU, USDA researchers, and then private industry. And I want to start out by acknowledging Stephen Guy at WSU, Bill Schillinger at WSU, Rebecca McGee, who is USDA ARS, who's done a lot of the breeding work, Howard Nelson, who's with Central Washington Grain Growers. He's a real big driver of the production of winter peas in the area, and then Kurt Braunwert at Progene, who's also a private breeder working in winter peas. Winter peas are suitable all across the agroecological classes of the inland Pacific Northwest, so they can fit into the annual zone or the transition zone or into the grain fallow zone. They offer many rotational benefits that we'll get into, and they provide economic diversification for systems that are predominantly wheat. And so really the AEC that we see them fitting into the best is the grain fallow rotation, because that's the rotation with the least opportunity for diversity at this moment with not being able to grow any spring crops. Here are some of the advantages or benefits of growing winter peas in your rotation. Biological nitrogen fixation, which allows you to basically get free fertilizer. Low soil acidification during winter pea sequences. The options for controlling grass weeds is a real big, I would say probably one of the largest drivers. Reduced disease and pest pressures on your wheat. So you're just by rotating out of wheat for a few extra years, you're getting a reduction in the pests. Moderate water usage. So essentially you are getting a good crop, but you're not using up as much of your water. And so this leaves more water left over for your winter wheat. The residue is easily managed. This is something we'll talk about a little later. You have a different C/N ratio, so it breaks down a little faster. And then also good water use efficiency and planting and emergence flexibility. And here's a video from a farmer in the area, or up in the Wilbur area, Wilbur, Elmira area, Mark Scheffels, and he'll talk a little bit about why he's growing winter peas.
Behind me, we've got about 580 plus acres of peas, which total down here in the Wilbur area this year, we have very, very close to 2,000 acres of peas, and only about 1,300 acres of winter wheat. Also have some crop up in Davenport. But this is a big year for Wilbur, and Davenport will have some fallow. A little bit of history on this farm. This farm traditionally was wheat fallow back in the day. My father and his brother realized that limited monoculture rotation was problematic for winter annual weeds and diseases, so they incorporated barley. Tried to run a 3-year rotation. That worked fine on wet years, but the barley tend to be a pretty big money loser on drought years. So if we were running anywhere from 14 inches of water to 15, we could be pretty good with barley. If we're running under 12, sometimes down to 8, you knew it was going to be a disaster. That problem became dramatically worse probably 10 years ago when wheat prices jumped up and all our expenses followed them. At that point, it rapidly became about 2.5 times more expensive to plant a cereal crop than it was prior to there. So the spring crops that were even iffy before that point economically became very, very dangerous on a dry year. If you planted a spring crop and ended up with 20 bushel instead of 40 bushel, you were going to lose a lot of money. So then we're back to winter wheat fallow, which is what most farmers do in this 12-inch rainfall area. But the problem with that is that now you're back to monoculture. Goat grass has become quite prolific in the area, and cheatgrass always has been a problem. So in that rotation, you are going to have to try to use selective control of those grasses within a wheat crop. There are products available, but they're going to be damage control. Those are going to be perpetual because they'll salvage a crop, but they'll never reduce the seed bank of the weeds to the point where you don't have to use them every time. So what we really wanted was a winter crop that could be planted on fallow, and other than wheat, we could control weeds in.
So just to emphasize what he said there is that they really needed a winter crop up in that region because the spring crops did not really offer a viable economic long-term opportunity. In the wetter years, you're able to grow them, but in the drier years, you're going to end up losing money in that area. Another rotational benefit is that winter peas actually fix nitrogen using a symbiotic relationship with rhizobia. And there's some thought that the winter peas might actually fix more nitrogen than the spring peas. So there's not a real great estimate of exactly how much nitrogen you're getting back from spring legumes. Some of the fertilizer guides will say around 20 pounds per acre, but the thought is with winter peas that is probably higher. There's some work done by Stephen Guy that shows it could be up to 30 pounds per acre. And one way to tell if your legumes are actually fixing nitrogen or not is just to cut the nodules open and to actually look at the inside and see if there is red in there, because there's leg hemoglobin, which grabs the oxygen away from the rhizobia, giving it anaerobic area to work in. Another advantage winter peas have And this is especially, as we'll see later, as opposed to winter canola, is that they can emerge through when they're planted really deep into the soil. So if your moisture is down deeper in the soil, winter peas are a great option because the hypocotyl can come up several inches. And here's a picture of one that's maybe coming up 5 or 6 inches through the soil. So that's a tremendous advantage. Mark mentioned this a little bit earlier, but there's also a huge advantage for controlling winter weeds. And we'll play a little video now of him actually describing more in depth how using winter peas helped him control grass weeds.
The peas offer many advantages on grassy weed control. We can eliminate grasses out of peas just about with the same effectiveness that you can, well, actually as good or better than you can eliminate broadleafs out of winter wheat. So that way we can nail broadleaf weeds when we grow winter wheat, and we can nail and get rid of grassy annual weeds when we grow peas quite successfully. I think in some of the video that'll be shot today, we'll see places that did not get sprayed for grasses because they were simply too wet on this year. And the difference you'll see in those shots is going to be quite dramatic. You'll see some very, very bad cheat infestations, and luckily that will be on less than 1% of our acreage. So why we don't like to see those out there, it's going to serve a purpose. It was a check block we didn't want to have, but due to some very, very wet fields and getting sprayers stuck, that's what we have this year.
So just Mark re-emphasizing there that winter peas have really helped them control the grassy weeds and saved them from essentially just doing damage control, especially on the downy brome. Winter peas also have a higher water use efficiency when compared to wheat. So you can see in this graph here that water measurements were taken in late March and in harvest in August, and that the winter wheat, especially deeper in the profile, is using up more of the water than the winter pea. And if you just look at this, you can see that essentially what you're going to do is you're going to leave some water down lower in the profile with the winter pea, and this could actually translate into more stored water for your subsequent years of winter wheat. So that's another advantage you have, is essentially saving some water. I actually saw this in person when I was up visiting with Mark around harvest. He and I went down 5 or 6 feet and were able to find starting moisture in the second and third and fourth foot. So there was quite a bit of moisture left over. And this work here is thanks to Bill Schillinger out at the Lind Field Station. Just looking a little bit at the economics of it and simply looking at the gross profits without considering the inputs, you can see these 3 locations here, Ritzville, Waterville, and Sprague, with different mean annual precipitations of 12, 15, and 16 inches. And you can see that each of these locations, the yield goes up with increasing moisture, and the price is set the same, but the gross per acre in Ritzville, so in that grain fallow region, was $325 an acre, and then Waterville was $660, and Sprague was $690. So those are pretty good gross profits. And then you start thinking that you didn't have to add any nitrogen because you were using a legume, and it can look like quite a good option economically to be growing these winter peas. There is some variation in the prices of them depending on what the quality of the peas allows. So if peas can be grown for cover crop seed or for food grade consumption, there's a higher price for them than if you're growing peas for feed, which is traditionally winter peas were only grown for feed. Now, thinking a little bit about what you would have to change moving from winter wheat to winter peas in your rotation, there are a few considerations. First off, if you are doing a winter wheat fallow, winter pea fallow rotation, you really need to think how you're going to conserve your residue, because you're going to have 2 fallow years there, and the pea residue is going to break down the wheat residue faster than the wheat residue would break down on its own because of the low seed-to-N ratio of the pea residue. So there's a few things that might help with that. One is, first off, you pretty much have to be doing some sort of reduced or conservation tillage or no-till in order to not just have soil that will dust off during the windy season. And then you also can modify your combine headers to help them go through the peas, which are going to be all entangled with each other, so it's going to be a bit more difficult to go through. And here's a video of Mark just describing some of the changes that he made to his drill to make it better for seeding peas as opposed to what he had been traditionally seeding wheat with.
With the direct seed farming, most openers that are not disc openers have a point similar to this, with a paired row with the seed coming out here and bulk fertilizer coming out here. But when you start planting a lot of winter peas, which don't require bulk nitrogen, and the peas happen to be a low residue crop, it is very, very wise to disturb and reduce your wheat residue. So you want to reduce that as little as possible. So we pull these bolts, pull this point off, put the seed tube here. So now all our seed for both garbanzos and winter peas go down to the deep band. So then you're looking at an opener that is only a 1/2 inch wide with no paired row on the back. Peas also like to be seeded deep, so that allows it with very little draft and very little disturbance to put the peas fairly deep. We have modified this opener to put a little bit of starter down with the peas, but again, peas don't require bulk nitrogen, so that's pretty minimal.
Another modification that you can use when you're harvesting winter peas in order to cut through better with the combine is by putting a cutter disc on the edge of the header to basically separate it from the peas that will otherwise get drug in from the side and tangle up on the header. There's also side cutter bars, which are available commercially, but at least with the Mark's experience, they didn't work as well as just putting a disc on the side there, little self-manufactured PC made. So just in summary of should peas, there are some future research needs we need to be talking about. One is discovering what the optimal sowing dates are right now should be a focus. Improved winter survival is another area of focus. The Lynx variety has winter survival down to -5 degrees Fahrenheit, but it would be nice to get a little hardier pea varieties that way. Also, control of late emerging broadleaf weeds is an issue, and you'll see this when you drive by winter pea fields. It's not uncommon to see some mustard issues. Now, when you're rotating it with wheat, that can work out rather well because you can control mustard in the wheat fairly easily. And then thirdly, you can have a sensitivity to SU carryover, and that can be an issue. And just one closing thought from Mark Scheffels on this that I thought was really great about his thoughts on growing winter peas.
My biggest regret is that I've started this rotation full scale at 60 years old, so you don't get through too many rotations when you're 60 years old and you've got a 4-year rotation. I'd love another 20 years to do this.
Moving on now to winter canola and spring canola, and I've combined these two together because they have a lot of the similar advantages as far as what they offer in the rotation, although there are some nuanced differences that we'll talk about a little bit. But before we get started, I would like to thank the Washington Oilseed Cropping Systems team at WSU. They've been a big part of promoting canola in Washington, and they host winter workshops every year on helping farmers learn more about what it takes to get into canola, and a lot of the stuff that I'll be presenting today will be surrounding this. Canola and where it fits into the agroecological classes. Winter canola fits best into the transition zone or a little bit into the grain fallow region. You'll see people, especially up on the Waterville Plateau, out towards Elmira, that area growing winter canola, and down into Ritzville and further out on Highway 26 towards the eastern end or the western end of Whitman County, rather. You'll see some. And then spring canola is more well suited to the annual cropping region or the transition zone, where In a wet year, it can be used to fit into the transition zone as an additional diverse crop that can allow you to control grassy weeds and still make some profits. The rotational benefits of winter canola are that it has a really large taproot, and so that it can penetrate down through the soil layers, increasing infiltration and potentially breaking up compaction. From my observations looking at canola in the field, spring canola will do this to some extent, but not as much as winter canola. I think that has something to do with the timing of the planting, and also just the length of time that the root is in the soil and the overall size that the plant gets to. So it won't be uncommon to find really, really massive taproots in winter canola and then some all right taproots in spring canola. You also have increased weed control options. So there's a fair bit of Roundup Ready canola that is available, and there's also some other systems like the Clear Field system in canola that are available. There's also been some studies showing that you'll get a yield increase from following canola with wheat. There have been some mixed results on that. So a lot of farmers around Washington you'll talk to who have tried canola definitely say they see a yield bump. But there's a little pocket up near Reardon where they've actually seen a yield decrease, and there's some researchers looking into this now, and it seems like it could have something to do with actually changes in the microbiology. And once again, it just offers you an economic diversification. A big part of that is Viterra and the oil presser in Othello. And so we'll have some videos here of a video that was shot earlier about spring canola and exactly how farmers have found it fitting into their rotations and the advantages they see of using it.
Our crop rotation in the past has consisted of a lot of grass seed, Kentucky bluegrass seed and Timothy hay, and that has caused us to develop an annual weed problem, annual grassy weed problem specifically, and canola's come along at just the right time for us to try to combat that.
The technology and traits in spring canola today are far more advanced than even a few years ago. This translates to an opportunity for crop and chemical rotation.
I think it's always important to rotate your herbicides just as much as you do your crops. When you look at farmers in the winter wheat, summer fallow region, they rely heavily on one group of herbicides for the grassy weed control, and it's almost exclusively a group 2 herbicide. By incorporating a canola into it, whether it be winter canola or spring canola, you can get some variations in groups of herbicides out there, control some weeds, and that will do a lot of the research shows that just incorporating additional groups of herbicides help minimize the chance for herbicide resistance.
The canola is a viable product for us now that we have a crushing plant. There's incentives in that to keep a certain number of people involved. But now that we have a crushing plant, I think canola has a great future for us here.
Thinking about some management considerations when we're talking about putting canola into the rotation, unlike winter peas, it does require nitrogen, and there are some differences between the requirements for canola and what you're used to thinking about with wheat. So first off, thinking about the nitrogen rate, the unit N requirement for wheat seems to be pretty stable throughout different yield potentials, but it actually changes with canola. So it's important to look at your unit nitrogen requirement in relationship to your yield potential. And so that's one difference that you should be aware of when you're planning your nitrogen treatments for canola. Also the timing. Specifically with winter canola, it's really good to think about split applying or not applying in the winter and applying in the spring. And this gets into an interesting question of winter survival that we'll talk about as one of the issues with winter canola. And then nitrogen placement is really important. Because you have a taprooted crop, you have to make sure to place to the side and down if you're placing a form of fertilizer that could be toxic to the root system. And that ties into this third point, which is nitrogen source. Urea is much more toxic to canola roots than some of the other sources. Specifically, UAN, solution 32, has been shown to be quite a bit safer than using granular urea. This leads us right into some of the challenges of growing canola. I would say one of the largest that you'll see when you're driving around talking to people who grow canola or just looking at fields is emergence and establishment. This is a problem in winter and spring canola, but I think it's more of a problem in winter canola, as you have to figure out how to get it to survive over the winter. Winter survival, this is a uniquely, obviously, winter canola problem. Summer heat, this is a winter and spring canola problem. You can, especially when it's blooming, you want it to keep blooming as long as possible to increase the amount of seed pods that get pollinated, and heat stress can reduce the bloom or shut off the bloom. Another limitation is just the environment during the planting window. So unlike the winter peas, you don't have such a strong hypocotyl that can push up through 6 inches of soil. You'll have to seed them a little shallower than you will with winter peas. And then also sensitivity to the imatazolines and sulfonylurea. And this is an issue in winter and spring canola. So just a little more detail on the emergence side of things. Poor emergence can be due to many factors. It can be having to plant the seed too deep, or applying fertilizer too close to the seed, or planting into too dry of soil. And so now I'll have a little video from my dissertation research, which actually shows what happens when a canola root grows into a urea fertilizer ban. So this is a problem that is unique to canola over wheat, as it is a taprooted crop. And if you lose that taproot, you lose a lot of the advantage of growing canola. As we mentioned earlier, if you're growing canola maybe to break up your plow pans or to reduce compaction in your soils, and you kill the taproot, you can really easily lose that advantage. And so this is where you really need to think about your nitrogen source and your rate and your placement. You can see what happens in that video is that the root stops and then it starts to shrivel up and eventually send out lateral roots. So at lower rates, the roots will actually adapt and get around the fertilizer band, but at higher rates, it'll just kill it straight out. Moving on to talk a little bit about winter survival research and where that research is currently. There's a few things to think about. Is that when you're talking about winter survival in canola, you have to be concerned about the plants going into winter at the right size. So plants that are too small, in the cotyledon stage or just like 2-leaf stage, they will freeze out over the winter, most winters, and have trouble. Now plants that are too long can get their meristem up above the soil protection, and so as it freezes, they will actually die off, and you can lose your whole stand that way. WSU is currently experimenting with a few techniques to increase winter survival, which are winter grazing, or fall grazing rather, with cattle, or fall mowing, to see if you knock the plants down and keep them small, does it up your chances to survive the winter with canola. If you're interested in learning more about canola, I would just point you towards this resource here, this website that's on the slide, which is the main page for the Washington Oilseeds Project. And it's really good. It has a lot of information on it. Something you'll find there is variety trials. These are full field variety trials, so they're large strip trials in both winter and spring canola. And they will give you the different varieties that were planted and the average yield, and essentially if there was a statistical difference or not. So in this particular example, Odessa on the left is irrigated, so there was no real statistical differences there, whereas Ralston and St. John are both dryland locations, and you can see some significant differences between the different canola varieties. So this can give you an idea of, in your area, what varieties could be planted. Now zooming back out to the strategic picture and what this looks like over the whole region, looking at this map again of the agroecological classifications in the inland Pacific Northwest, you can see that a lot of the adaptations we're focusing on are in the grain fallow or the annual crop fallow transition zone, and how we might diversify these locations. But you can't diversify your agricultural system unless you have many places, many pieces in the right places. And so a recent paper that's a part of the REACH project focused on agricultural adoption to climate change, and Dr. William Pan was the lead author on this paper, but it really was a combined effort from a ton of different researchers to look at what drives the change in these systems to be either intensified or diversified. And it just focused on the decision inputs that go into what producers actually do, having to do with the weather, the markets, the current policy, agronomic knowledge. Do we know how to grow this crop? Capital, what new equipment needs bought, what old equipment can we refit, and then also the ability to finance it. So banks, loans, FSA, and things of that sort. And then this influenced the producer plans, if all the decision inputs are there, where they can design their cropping system to integrate these new crops. If there's crop-specific storage, so back to that capital question, do you have to build a whole new, for instance, with canola, the crusher plant was a big reason that canola is now able to be grown in the region. And then also just thinking about how does this benefit the rotation as a whole? So looking at the economics over the life of the rotation and seeing if it's paying off better than the conventional rotation. And then finally, from this, you have farm outcome, which is more crop products, more diversity, and hopefully higher profits from that. So just looking at what this model would look like in the grain fallow region, this adoption of diversification specifically, you can see that on the left we have a winter wheat fallow as the conventional rotation with conventional harvest techniques, tillage, and uniform nitrogen and weed management. The next step along the process towards adaptation is winter wheat fallow, but with conventional harvest, reduced no-tillage, chemical fallow, and uniform nitrogen weed management. So what you've done is basically you've reduced your tillage in this region, which is, I think, fairly widely adopted out in the winter wheat fallow region. The third stage of adoption is actually changing the rotation. So that's where you go to winter wheat fallow, winter pea, or winter canola, and then fallow. And so now what you've done is you spaced out your wheat in your number of years, so you diversified economically. And also what we see is increased standing stubble harvest, so using things like a stripper header, again, doing the no-till, precision nitrogen, and integrated pest management, and then also organic amendments such as manures and biosolids in those soils that traditionally have low organic matter. And the way these are laid out is a win-lose situation where the conventional you may be making economically, but long-term sustainability is decreasing. And then your next scenario is a win-neutral scenario where you're making it economically, but you're just kind of staying stable as far as long-term sustainability. And then finally, a win-win scenario, which has good long-term sustainability and short-run economics. Similarly, if we look at this in the annual cropping region, you see a really similar pattern developing, except for you have the incorporation of more diversity in your spring crops. So instead of just spring wheat or spring barley, looking at spring canola, spring legumes, and I think in the last few years, especially, you've seen chickpeas take off, which are a spring crop. And it's interesting because I was talking to a farmer from down in the Genesee region, and he was talking to a farmer from up in Reardon, and the Reardon farmer was saying that he was glad to see the chickpeas come in as diversity, and the Genesee farmer was saying that's not diversity in our area. So diversity of cropping systems is kind of locally defined. To just zoom all the way out and put this in the context of how agriculture is changing in the inland Pacific Northwest, these are some final thoughts. After more than 100 years of wheat-dominated agriculture, we are seeing increased opportunity for diversity in the inland Pacific Northwest. Some of the most promising crops at the moment are winter peas, winter canola, and spring canola. But you won't get any adoption of these new crop systems unless these windows of opportunity, which are currently happening, are taken advantage of by fieldmen, agribusiness, policymakers, and researchers at the same time in order to realize these opportunities and actually diversify our landscapes and hopefully increase our long-run sustainability, both economically and for the soil. And then finally, I'd just like to acknowledge everybody that did the work leading up to this. I'm really young to be talking about this, in all honesty. The no-till movement in the Pacific Northwest has been going for quite some time and has been the work of WSU and a lot of grassroots work by farmers and the establishment of the PNDSA. Also, as I mentioned earlier, people who have worked in the development of winter peas, Stephen Guy, Bill Schillinger, Rebecca McGee, Howard Nelson, and Kurt Brownwart, and then the Washington Oilseed Research Team at WSU and U of I. And I'd like to especially acknowledge Dr. William Pan, my mentor, who was heading that project for quite some time, and then Scott Holbert, who is the chair of Plant Path at WSU and also heads the project up, and then Karen Sowers, who's on that project and who's the coordinator of it and does a fantastic job at talking to growers and talking to researchers and keeping them all working together. And finally, for USDA NIFA, which made this presentation and a lot of the research leading up to it possible. Thank you.
If you plant winter peas in the fall, when do you expect to see the nitrogen fixation? They're curious about using it as a winter cover and still planting a spring crop in an annual cropping region. So Isaac and Bill, any responses to that?
Yeah, so John, I wrote a little answer there in the question board, but in summary, yes, you would expect to see some nitrogen fixation over, I think especially in the spring before you burned it down. So it would depend on your burn down time. And then also because you're not taking the plant to harvest, you wouldn't be harvesting the peas off. So the nitrogen that's leaving in the pea crop would actually be staying in that case. However, you won't be getting all of the in-season nitrogen fixation that you would see if you grew a complete crop of winter peas. I was really surprised when I've gone out and dug in winter pea fields just how late the nodules will be still red.
All right. Any comment on that, Dr. Pan?
Just a couple caveats that, if these winter peas are going to be sown into fields that have never seen legumes before, and so there won't be large rhizobial populations in those soils, so inoculation is critical. And these nodules do take time to develop. So, and then the other factor is that if you're following winter wheat, that perhaps you had a low yield and have a lot of residual nitrogen, that's going to inhibit nitrogen fixation. The peas will actually work more as like a cereal crop in taking up the inorganic nitrogen.
Great. We had a request to check out this video again. It went pretty quick, and I actually missed what was going on here too. So, Isaac, do you want to explain what's going on? We're going to look at the canola root issue, the taproot issue here again.
Yeah, so I'm sorry that didn't line up quite right and with the presentation. What happens in It's chopping off the bottom here, but that taproot is growing right into a, if you could pause it there at the end.
Sure.
It's growing right down into a urea band, and you can see that shrinkage starting at the base there, coming up from where the tip of the taproot is, and then spreading up the taproot. That's actually the root dying back. And then at the very end of the video, you see some lateral branches start to pop out as the canola attempts to adapt and get around that fertilizer band. So that's actually, I did a lot of these root videos for my dissertation, and we were trying to establish essentially what was a safe rate to apply fertilizer at for the canola directly below. And really what we found is with urea, at least, it's really hard to get a low enough rate to make it safe for the canola to do no damage, but you can do some higher rates with solution 32. So yeah.
Great. That makes more sense to me, I think, that question. Thank you. We had a few questions here from A. Reyes, who asked, would you mix peas with another legume as a cover crop? If you do, what would work better? And same question for canola.
And so on that one, I'm more used to thinking of peas as a field crop that you're actually going to harvest. So I would really, around here at least, I would be looking mostly at, winter survivability and looking at other legumes and how they would compare on their ability to overwinter and still fix nitrogen in the spring, maybe before the burn down. And then with the canola, it's sort of the same thing. What I see in cover crop mixes out this way is if you're going to get a brassica in there and you're going to try and break up a hard pan, it's probably better to use like the daikon radish, the sort of tillage radish idea that has a little stronger, a little bigger taproot than even winter canola does. So as far as cover crops, I don't know that, I mean, you could use these in cover crops, but I'm not sure that that's what the focus would be. These are more for advantages you can have and still be making profit on a crop.
Yeah, I would just add to that the cost of the pea seed, it would be a consideration, and I'm guessing that the edible peas are going to cost more than say a forage pea or Austrian winter pea or something like that.
Great. Another question from Paula Gunderson asking, on dry land, has anyone tried to do winter peas and then follow that with winter wheat without a fallow in between?
I think that would require the perfect rain. I don't know off the top of my head of anybody doing that, but I'm sure, especially as you get into the wetter regions, that I bet you could pull that off, because really what you would be looking for is for your seed bed. So, like the top 6 inches to get wet if you had that water, and you'd want to do it with testing and seeing what's in your profile already for water. But if you had a good deep profile and you got an early rain right after your pea harvest, I think you could probably pull it off.
Yeah, and Bill Schillinger just published a paper in Frontiers about, I think it's got some information on water drawdown by winter peas versus wheat, and there is less water use, but yeah, it'd be seasonally dependent, as Isaac mentioned.
Great. I'm pasting into the chat box right now a comment by Sanford Eigenbrod, who was the lead on the REACH project. And he just wanted everyone to know that they're studying insect and virus pressure in winter pea, and they're looking for cooperators. So if you're interested, they'd like you to get in touch. And I have Sanford's email and phone number in that chat box if you're interested in participating in that. With that, Sanford also had a question. Someone in one of the video participants had mentioned planting garbanzos. Is there any sense how that crop works in diversification alternatives in lower rainfall zones? Isaac, I think you kind of touched on that a little bit at the end of the video where you said it's not really diversification in some regions, but do you have a response specifically in lower rainfall zones?
Yeah, so actually up in Mark's region, that would be diversification. And on a year like this, I mean, there was a lot of water and the garb price was really good. So in right next to one of Mark's winter peas field, he actually had put in a garb field. So I think people that are watching the markets and watching their moisture and looking for opportunities up in that grain, even that's over more in the grain fallow region and in the transition zone, will try stuff like that.
Great. Okay. And another question saying, do you happen to know what are the main traits that are being worked on by canola breeders at UI and WSU?
And I'm actually not superly up on what they're working at U of I and WSU. I know some of the private groups are really interested in extending bloom. So especially in the heat, trying to get the canola to bloom for longer is one thing. Bill might have some better input on that.
Yeah, I believe Jack Brown and Jim Davis are also working on that, and working on heat tolerance and water stress tolerance, and also herbicide resistance. But yeah, it's been amazing how commercial companies have come in with a lot of different choices for canola varieties in the last 5 to 10 years. Really changed the game.
Great. That looks like all the questions we have. Again, I want to thank Dr. Madsen and Dr. Pan for participating and for making that great video. It's really well done. Next Monday, we're going to have nutrient management and precision application technology. Same time, same place. You can find the link, however you found the link to get to this one. I also want to plug the Climate Learning Network, climate-learning.net, which is not on that page that you're looking at right now. We do our own webinar series, and our next one coming up is December 7th. So this will be in the middle of all of these. We'll be talking about the CONSERVE program, which is a transdisciplinary research, extension, and education program that is at the nexus of sustainable water reuse, food, and health. So if you're interested in that, go to climatelearning.net or climatewebinars.net and sign up so you can be on our mailing list and you can find out about all of our other webinars as well. And thank you all for attending. We'll see you next week, same time, bright and early, next Monday morning. Thank you everybody for attending, and I'm signing off. Thank you.